Hello, friends. Andrew Carlson, 44 years old, was taken into custody by the FBI in March 2003. Newspapers said this man was extremely lucky. He had made more money than anyone else in stock market history. In just 2 weeks, his $800 investment grew to $350 million. He was suspected to run a scam with the FBI. He was a trader with insiders. In response to an inquiry, Andrew claimed to be a time traveler. He said he had traveled from 250 years in the future, and that he made an investment in equities because he was aware of their performance, and achieved the remarkable outcome. The FBI was surprised at this. He was lying, and the FBI was certain of it, and it was their responsibility to expose his deceit. Further investigation revealed that there was no record of Carlson prior to December 2002. Even more unexpected was the fact that Carlson had to show up in court for his bail hearing on April 3rd, but he had vanished and was never seen again. Was he truly able to travel through time? Does the ability to travel across time exist? Or is it only fiction in books and movies? Let's take a scientific look at the idea of time travel in today's video.
Wait, are you talking about a time machine?
You know the rules of time jumps, right?
Time travel, a concept that has been explored since the early 1900s.
I have no idea what we're talking about time travel here either.
H.G. Wells wrote his groundbreaking book, The Time Machine, in 1895. The term time machine gained popularity after this, a device that can transport you both into the past and into the future. It allows you to go back in time. Despite being science fiction, this book served as an inspiration for a number of physicists and philosophers. Time travel was the subject of numerous films in addition to serious academic publications. If we give it some thought, we may divide time travel into many categories based on how it actually occurs. To further grasp this idea, let's first look at science fiction movies. There are numerous types of time travel. One-way travel to the future is the first. You can't go back once you've traveled to the future. One-sided time travel is the reason it is. One such example is interstellar film. In it, a time traveler goes to the future, but when he returns to see his family and other people, they have aged. A few had even lost their lives. An instantaneous time jump is the second method. A time machine allows one to immediately jump from one moment in time to another. The movie Back to the Future featured it. The girl who leapt through time is another example. The third possibility is that time is moving around the time traveler while they remain motionless. The movie Harry Potter, Prisoners of Azkaban presented this, when the time turner is used by Hermione. Slow time travel comes in at number 4, as seen in the 2004 motion picture Primer. The time traveler enters a box and travels back in time by 1 minute for each minute he is inside. He had to stay in the box for a day if he wanted to go back in time. The fifth is traveling across time at the speed of light. This was shown in the 1979 film Superman. In it, Superman traveled back in time and flew faster than light. Which of these theories of time travel is genuinely possible in the modern era, in actuality? In the future, which direction would be achievable? And which approach is completely unscientific and unattainable? Don't be shocked if you believe that all of these are science fiction, impossible, and garbage. That is untrue. Even now, it is possible to accomplish some of these. In general, time travel can be divided into 2 categories. Going into the future is one thing, going back into the past is another. First, let's discuss going into the future. Albert Einstein's theory of special relativity serves as the foundation for scientific predictions and explanations of time travel. Einstein was the first to propose the idea of time dilation. Time was thought to be unchanging before Einstein, whether you're close to a black hole, on Mars, or on Earth. It was thought that time was a constant element. This was stated by Isaac Newton, one of the world's most renowned mathematicians and physicists. He believed that the flow of time would be constant, independent of the position or the speed at which one is moving through space. The first to deny this was Albert Einstein. Newton was incorrect, he said. Time is not constant. Time, he said, was like a river. Just as water in a river can occasionally slow down and then speed up, so too does time flow, which can occasionally slow down and occasionally faster, based on gravity and speed. Indeed, Einstein claimed that if the speed and gravitational force could be altered, time might speed up and slow down. We call this time dilation. Similar to how your pupils widen when an object's speed increases, or when it feels a greater gravitational pull, time also dilates. In fact, how had Einstein found this? It's a lengthy explanation, so we can discuss it in another video. There are essentially 2 methods for dilation of time. First, speed. If you are sitting inside a rapidly moving object, like a spacecraft or an airplane, time slows down more for things that move more quickly. compared to one who isn't moving as quickly. If I had to give a real-world example, I would say that if you had 2 clocks, I would keep one with me and place it on the floor. Additionally, I send you on an airplane with the other clock. The aircraft completes one orbit of the planet before landing. When comparing the 2 clocks, we see that even though they initially displayed the same time, the one you brought on the plane would now display a few nanoseconds behind the other. The time on the 2 clocks would differ due to the fact that one clock was moving more quickly. Kinematic time dilation affects it. This isn't anything I made up. In 1971, an experiment was conducted. The atomic clocks were used because it was necessary to measure time precisely. Additionally, it was observed that the time displayed by the airplane clock declined behind that of the other clock. The Hafele-Keating experiment was the name given to this. Einstein's hypothesis of time dilation had been validated by this. The clock on the airplane does not necessarily indicate that time is slowing down. Instead, it indicates that time is a relative concept. Time slows down in our relationship if we look at the airplane's clock from the ground. Time slows slower because we can see it. Time would continue to pass as it did for the passenger on the airplane and the airplane's clock. Theoretically, you could get inside a rocket that flies at the speed of light if we could construct one. You spend 10 years traveling at that speed inside that rocket. 9,000 years would have passed by the time you return to Earth. All things considered, it is currently scientifically possible to travel into the future if you so choose. The only issue is that this speed isn't available in any aircraft. Trying the speed of light is possible. However, we can construct more of these faster flying spacecraft and airplanes as technology advances. Slowly, it would become practical. The Russian astronaut Gennady Padelka is currently recognized for having accomplished the most time travel into the future. It's because he spent the most time in space, 879 days. Additionally, he was moving through space at a speed of 28,000 kilometers per hour. Thus, he has traveled into the future by 0.02 seconds. He is 0.02 seconds younger than the earthly population. It allows us to travel so quickly that we can make major time travel in the future. Don't be upset. Because Einstein established a different theory of time dilation. With the use of gravity. Gravitational force causes time dilation in a manner similar to that caused by speed. Time dilation would increase with increasing gravity. Einstein wanted us to visualize a fabric of space-time in order to visualize the time dilation caused by gravity. Consider a mesh, such as the one in this picture. Put balls on it as well. These balls can be thought of as planetary objects. This mesh would wrap around a ball more when it was heavier. The gravitational pull of the planetary object would increase with its mass. Jupiter has a stronger gravitational pull than Earth. The gravitational pull of the Sun is greater than that of Jupiter. Similarly, you can observe a curve with an object's gravitational force in the fabric of space-time. Time seems to slow down the closer you are to an object with a strong gravitational pull. For you, time would slow down. As you can see from this mess, time seems to slow down the steeper the collapse. This visualization allows you to obtain a rough estimation. In essence, this means that if you wish to travel through time in the future, you should spend some time close to Jupiter, the Sun, or another object with a stronger gravitational pull, like a black hole. Time would move slowly if you spent some time close to a black hole. If you are aware, the movie Interstellar also presented this idea. Its main character lands on a planet close to a black hole, and for every hour he stays there. 7 years pass for those who are not on the planet. That was the amount of timing dilation caused by the black hole in the movie. The depiction is accurate from a scientific standpoint. In fact, that is how it will occur. However, it is unknown if one can survive that near to a black hole. Black holes are thought to be the universe's heaviest things. There are also claims that light begins to distort around black holes. 3 years ago, a telescope captured the first image of a black hole, proving what was previously thought to be completely theoretical. This image was captured by the Event Horizon Telescope on April 10, 2019. On the internet, this picture got viral, since this is the first graphic representation of a black hole that has been rendered. In any case, I gave you 2 methods for going into the future if we return to time travel. The first is moving quickly, while the second is approaching a gravitational object with a high mass and a high gravity. I'll offer you another example of this from a practical point of view. GPS satellites orbit the Earth at a high speed and are farther away than the Earth's gravity than humans. For this reason, the GPS satellites allow us to see time dilation in both senses. And because of this time dilation, the scientists must continuously correct the time calculation on those satellites. The time on the satellites and the clocks on Earth will be different if they don't adjust the satellite clocks. GPS communication would be problematic. It's interesting to note, friends, that there is a third method of future time travel: cryosleep. It has also been featured in numerous movies. You probably remember a recent movie called Passenger. People were frozen while traveling on a spacecraft. They spent months and years in cryosleep, a state in which people are rendered incapable of aging. They're still asleep. Science fiction is what it is. However, NASA is actually working on creating a stasis chamber. For 2 weeks, astronauts would be able to sleep through the night in a frigid environment while experiencing mild hypothermia, a kind of hibernation. The idea behind it is that a body's chemical reactions would slow down significantly if it were kept cool. As a result, the body would conserve energy and age more slowly. In a related case in Japan, an injured man survived for 24 hours without food or water after his body entered a state of hibernation. That man's body temperature was merely 22 degrees Celsius. Usually, prolonged exposure to this level of cold might result in death. However, by some miracle, I'm not sure what it was, this man not only lived but also fully recovered from that state the moment someone else found his body. According to medical reports, his body was not permanently damaged. His brain was uninjured, and his organs had slowed down. One technology that might be developed in the future is cryosleep, by a space organization such as NASA. We will have to observe and wait. One thing, though, would have caught your attention. Every method I have discussed up to this point involves time travel into the future. How about the past? Is it possible for us to realistically travel back in time? In the James Webb Telescope movie, I kind of explained one method to you. We can receive a glimpse of the past, but we are unable to travel into the past at this time. Even though light moves quickly, it takes a long time to go from one place to another. If we measure distance in light years, it can take years for light to reach some locations. Therefore, the light would be from the past if we could arrive somewhere before it arrives, and then turn to face the light that is coming. We are able to view the past in this way. Is it possible for us to go back in time? The renowned physicist Stephen Hawking staged a party at the University of Cambridge on June 28, 2009. The party had champagne and balloons, but what made it unique was that nobody showed up, even though everyone was invited. This time-traveling party was launched by Stephen Hawking. This gathering was open to anyone who might be visiting our timeline from the future. The purpose of this humorous experiment was to demonstrate that time travel is impossible. We would be surrounded by future time travelers if this were acceptable. Where are the tourists going back in time? How about we get to meet them? In theory, time travel to the past is not refuted by Einstein's theory of relativity. According to Einstein, a wormhole would form in the space-time mesh if an object were subjected to a gravitational pull so strong that it fell through the mesh. That wormhole will allow us to go back in time. It is stated that we would require a very strong gravitational field to do this, like the one of a black hole. The gravitational field produced by a spinning black hole may be so strong that it causes space-time to fold back on itself. It would produce the CTC, a close time-like curve. You can use this diagram to try to comprehend it. You may try visualizing it. Nobel Prize-winning scientist Kip Thorne thinks that tiny wormholes constantly form and then vanish in space. However, they are quite tiny, smaller than atoms, and we would have to open them up in some way if we wanted to pass through them. Expanding them would require a lot of energy. We would require negative energy in addition to normal energy. One type of anti-gravitational energy that would resist the structure of space-time is negative energy, similar to how magnets' identical poles repel one another. It would be repelled by negative energy in the same manner. This would allow one to travel through the wormhole and keep it for a long time. How would we capture this negative energy? How would it be made? It is something to consider. For now, this is only theoretical. However, it has a lot of weight because it is a theory put out by a scientist who was awarded the Nobel Prize. This may give you the impression that time travel is potentially achievable. However, there are several obstacles to overcome while discussing historical travel. We face significant challenges. I am referring to paradoxes, the grandfather paradox, for instance. This is how the paradox works. Let's say I travel across time and visit the past. In addition, I murder my great-grandfather. How would I be born if he died? I shouldn't be here if my great-grandfather passed away. And how could I have gone back in time and killed him if I had never been born? How would you describe this? There is a dilemma here. I'm either living or dead. This is illogical. This can be explained by a few possibilities. For instance, The multiverse theory. According to the notion, there was only one universe where what occurred once occurred. A new universe, or multiverse, would be created if you could go back in time and alter something. Thus, there are several universes where various events take place. Another dilemma that is connected to this is the predestination dilemma. It asserts that my current chronology is shaped by everything I do when I travel back in time and do whatever I want. According to this conundrum, certain outcomes are predetermined. The course of events will be determined by fate. No matter how hard you attempt to alter the past, the outcome of your efforts will be your current situation. I'll give you an example if you're confused. Let's say your friend has an accident and passes away. I sincerely hope it doesn't, but suppose you had a time machine and it does. Going back in time, you attempt to stop that accident from occurring. However, what really occurs? Going back in time, you did something that contributed to the accident, and then you discover that the accident happened because you traveled back in time and attempted to stop it. This was the idea behind a lot of movies. Predestination, 2014. The Time Traveler's Wife, 2009. Time Crimes, 2007. And 12 Monkeys. Overall, going back in time would provide a number of logical issues. It might never be feasible because of the contradictions that would arise. However, it is still possible to go to the future now, and in the future it will become increasingly likely. Additionally, it is currently feasible to catch a peek into the past. Thus, time travel is already possible in a way. And to a certain degree, it was the scientific reality, as demonstrated in movies like Interstellar. However, what about the narrative of Andrew Carlson? I kept quiet about it. Friends, the tale I told you at the start of the film was actually taken from the Weekly World News, a satirical newspaper. Yahoo News later printed it, and the story was reported by a number of other media outlets as fact. However, the fact remains that the story was satirical. Newspapers were spreading false information, which many took to be factual. It was essentially a made-up story. I hope this episode was educational for you. In the future, what other subjects would you like to see more videos on? Tell me in the comments section below. There are certain mysteries and unsolved topics that lack sufficient scientific explanation. Leave a comment with your recommendations. Many thanks for watching the video, dear friends.